Hello everyone, so I'm here back with another video. So this video is about Leetcode 67, add binary. So let's see what the problem says. Given two binary strings A and B, return their sum as a binary string. Simple. Input A is given as 1 1, B is given as 1, their sum is 100. Similarly this one as well. So before that, let's know what are the rules of binary addition. Alright. So they are 0 plus 0 is 0. Okay. 0 plus 1 is 1. Similarly, 1 plus 0 is also 1, and 1 plus 1 is 1 0. Okay, these are the four rules of binary addition. So let's try to apply them on the given examples. What is it? The first is 1 1 and 1. 1 1 1. What is 1 plus 1? It's 1 0. Is it? No. If during normal addition, we know that, right, that when we do something like this, say 8 plus 3, it's 11, right? We don't write 11, we write the 1, isn't it? And we take this carry as 1. We take it as carry, isn't it? So when we move to the next place, from 1st place to 10th place, we do 1 plus 1, 2. So this is our answer, right? We take carry whenever it exceeds 9. So similarly here, we write 0 here, but we take this 1 as carry. Alright, so this place is done. Now this 1 plus 1 is 10, write 0, carry 1, it's finished, so simply write here 1. This is the addition. Let's see the other example. 1 0 1 0 1 0 1 1 1 0 1 0 1 0 1 1. Right, 0 plus 1 is 1, simple. 1 plus 1 is 10, write 0, carry 1. 0 plus 0 is 0 plus 1. 1 plus 1 is 10, write 0, carry 1, it's finished, so simply add the 1 here. So this is our answer. Let's try some other examples. Say 1 0 1 1 0 1 1 0 0 0 1. Right, let's see. 1 plus 1 is 0, carry 1. 0 plus 0 is 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is again 1. 0 plus 1 is 1. 1 plus 1 is 1. Okay, let's verify. What is it? 1 0 1 1 0 1. 1 0 1 1 0 1 plus 1 0 0 plus 1 0 0 0 1. See, 0 1 1 1 1 1 0 1 1 1 1 1. Right, so that was pretty much the underlying concept. So how are we going to implement that in our given problem? Okay, how are we going to address this problem? Let's see. Let's take the examples only. What were they? 1 0 1 0 1 0 1 1. Now we saw that we are doing this sum from the last places, right? From then we are progressing further, from right to left we are coming, and they are strings, they're given as strings, so why not put 2 pointers in the last positions? We will do an addition, then we will move up, then we will come here. Similarly we will go like this, isn't it? So let's take 2 pointers here. Now the thing is, what is the rule? 0 plus 1 is 1, yes. 1 plus 0 is also 1, yes. 0 plus 0 is 0. What about 1 plus 1? We know in binary addition 1 plus 1 gives us 10, right? But we can't simulate that thing here. Like if we have 1 plus 1, we can't, there is no way we can get a 10. What will we get? Definitely 2. So we'll have to make something out of this 2. What can we do? We have a 2, but we know by the concept we actually have a 10, so we will have to manipulate this 2 in such a way that we are actually like having a 10. So this 0 will be added to sum and this 1 will move to carry. How can we do that? So let's try the value that we are going to add. 2 modulus 2 gives us 0, isn't it? If we get a value 0, right, that means we will add it to sum, fine. To get the carry, we will do 2 divided by 2, that is 1, yes. This will move to carry. So this is the special case, not special case, I would say general case, because every time we do the sum, we will add the value modulus 2 to sum, and the carry will be the value by 2. Okay, so we have a 0. 0 modulus 2 is 0 only, so sum will have get added with a 0. 0 by 2 is also 0, right? So we have a 1. 1 modulus 2 is what? 1 modulus 2 is 1. 0 sorry, 1 by 2 is what? 0. So this is pretty much about it. We'll simply, this is nothing but a formulation. So let's apply that here. We will have a carry, right? We'll have a carry. We'll have a string that will store our sum. Okay, so let's start. 0 plus 1 is 1, isn't it? So let's add that to sum. Okay, carry is 0, definitely. 1 plus 1 is 2. So that's where our logic comes into play. So 2, that means we have a 10. So what are we going to do? 2 modulus 2 is 0, right? That 0 we are going to add to the string, right? This 0 comes here. 2 by 2 is 1. That is the carry that that goes here, right? Okay, I and j also moves up. This came here, then this came here. Now it's here. Now 0 plus 0 is what? 0 plus 0 is 0. Plus carry is 1. We add this 1 here, right? Simple. Let's move up. 1 plus 1 is again 2. So what are we going to add to our sum? We are going to add 2 modulus 2, that is 0. And what is the carry? Carry is going to be 2 by 2, that is 1. 1. We come out. So we have moved out of bounds, right? We have completely iterated the two strings, and we are left with a carry 1. We'll simply add this here. That's it. But you see, this is, we came this way, right? But we added this way. That means our string is not correct. Like, we have to reverse it. Though it seems same now, but if we do another example, we'll get a different answer. Okay, let's try this one, then you will understand. 1 1 1 I j. 1 plus 1 is 2, right? 2 modulus 2 is 0, and 2 by 2 is 1. This is our carry. Answer string, this goes here. Carry 1 ij. 1 plus, there is nothing, so 1 plus 1, it's again 2. 2 modulus 2 is 0 0, and 2 by 2 is 1 again. This is our carry. Out of bounds. This already moved out of bounds. This is now finally out of bounds. So we are left with a carry 1, so we'll add that. At the end, reverse 1 0 0. Right? So let's apply this logic in our code. So what do we need? We need an answer string. For that, we are going to use a string builder. Why? Because string builders are mutable, they are efficient. Okay, new string builder, right? 2 pointers at the end of both the strings. Let's say int I equals to a dot length minus 1, and b equals j equals to b dot length minus 1, and we need a carry, right? Okay, now we are going to start like we are going to iterate. If any of them is in bounds, we will do something. What will we do? We will need a sum variable, right? Let's say sum equals to 0. Then if I is greater than equals to 0, that means if I is bound, I is in bounds, what are we going to do? Sum plus equals to a dot char at I minus 0. What did we do here? This very simple thing. A dot char at I means the character at index I. Minus 0 means, like, when we are taking the ASCII value, like we are subtracting the ASCII value to get the, like, the number. Like, this is out of the scope of the solution, but still let me, like, explain. Say um let's take, say, A. Okay, the ASCII value of A is 97. and the SKI value, if we subtract A from A, the SKI value of A is 97 again. So 97 minus 97 is 0. Okay, B 98 minus A, the SKI value of A is 97, it's what, 1. So see, 0 1, for similarly for C we'll get 2. So what about this numbers 1 and 0? What was the SKI value of 1? 0 is 48, 1 is 49. 0 is 48, right? If we subtract this, again 0, this is 48. What do we do? What do we get? A 0. Similarly for 1, minus 0 is 49 minus 48, that is 1, right? That's what we are doing here, right? Now in the second string also we need to check if j is in bounds. If j is in bounds, sum plus equals to b dot char at j minus 0, right, at the end. So in sum we have added in sum we have first added 0, then first added 1. What are we left to add? The carry. We can just initialize it with carry only, so that we don't need to add it later on. Like we would have done sum plus equals to carry, but why not initialize it with carry only? Now we have done the addition. Now what are we supposed to do? In this string we are supposed to add the what? Say if we have 1, we are supposed to add this 1. If we have 2, we are supposed to add 0, that is 2 modulus 2, 1 modulus 2, 0 modulus 2, right? So whatever the sum is, sb string builder dot append the sum modulus 2. And what is the carry? Carry is sum by 2. Try to remember, if we added 2, we added sum by 2 by 2, that is 1. 1 is the carry. If we had a 2, we would have added 0, right? So sum modulus 2. At the end we check if we have a carry left. If we have a carry greater than 0 left. If it's a 0, we don't want to add. Otherwise we will add string builder dot append carry, right? And then we want to reverse our string, right? Because we added the numbers in a reverse fashion, and then we do the reverse to string. This converts the string builder to a string, and then we return. Oh, oops, sorry. Okay, we forgot to decrement our variables, so we are moving from right to left, right? So this is it. Let's try to run. There we go. We can decrement them right here as well. This is posting decrement operator, so this will work the same. Submit. There we go. So this is the simple solution. I hope all of you understood. Now what will be the time complexity of this solution? So let's see. We have two strings, right? 0 1 0 0 1, say, and let's say 1 1 0 1. What are we doing? We are individually adding this to sum, then again this to sum, and before that we are already initializing sum to carry, right? And we are moving up this like that. But when iterating either of them is done, we'll still keep iterating the longer string, right? So this is the longest string, so we'll keep iterating it till the end. So the time complexity is totally depending upon whichever string is the longest. So the length of this is m and the length of this is n. So time complexity is nothing but maximum of m and n. Whichever string is the longest, we are going to do as many iterations as the length of the longest string. Simple thing. So this is going to be our time complexity. So time complexity is going to be maximum of m and n. Say m is the size of A and b is n is the size of B, and our space complexity is going to be constant. We are not using any extra space. All right. So that was pretty much about it. You can move to the solutions section as well and see what other people have done. You will find many different things. You can see my solution as well. All right. You can definitely upvote it. Right. So that was it. See you in the next video. Bye bye and happy Valentine's Day.